Okay, so yesterday thank you. We solved some equations. We're going to get into a little bit more of the solving. This says and inequalities, but it's really just equations, and I messed that up too. All right. So I told you yesterday we would get into the squaring and quadratic stuff. So when we want to square trigonometric functions or raise them to any exponent, really, we do not want our notation to be overly complicated or ambiguous. Ambiguous means we're not sure what it means. Could mean one thing, could mean another. So if we wanted to square the variable x, it's very straightforward. We just write x squared. Okay? I mean, that doesn't change. But trig functions can create a bit of an issue if we're not careful. If we wanted to, hello, thank you. We wanted to square the expression sine x. That's different than just doing the x, so we have to be careful. If we write sine x squared like that, all that's doing is squaring the variable x, just like it looks, okay? Which is a possible thing that we would get. We're not really going to see anything like that. You would definitely see that in calculus, but that would mean, like, if I want the sine of pi thirds, I would square pi thirds before I took the sine value. That's what this implies right here. But that does not, it's not squaring the entire expression. So we would have to, if we want the entire expression, we would have to put it in parentheses like this, okay? Sine of x squared, which means we would take the sine of pi thirds, get that value, and then square it. That's what that means. That is more like what we're going to use, but you should probably never really see it written that way. There are times where you want to rewrite it that way so it makes more sense to you, but that also is more of a calculus thing. That's not really a need for us, but we need to know what it means. All right. So the notation we actually use to do something like this. If I want sine of x to the nth power, so I find the value and then I take it to whatever power, we would write it as sine, and we put the power on sine and then x. So sine to the nth of x, or sine squared, or sine of x squared is sine squared x. That means we find the value, then we square it. Okay, we're not squaring x, we're squaring the sine value. But that's how it's written. Okay, that's your notation there and what it means. Probably something that you haven't seen before. I don't think it's too difficult really to wrap your mind around. It's just you haven't squared trig values before. So let's look at example 6. We're given function g here. It says, what are the zeros of g? And it gives me this interval. Okay, so I'm not going to have an infinite amount of answers. I'm only going from 0 to 2 pi. 2 pi is not included. 0 is. That's something we need to pay attention to. And don't just assume that's what it is. Pay attention to what it is in case they decide to change that up. Okay, and we'll probably end up working one where I change it up so you at least know what to do if you saw something different. But if I want to know the zeros, I'm just going to take this and set it equal to 0. So 3 minus 4 sine squared x equals 0. And then we're going to start the exact same way we did yesterday. We're not going to make up any math because there's trig stuff in there. So what would be the first thing you want to move? The 3, okay? I could move this whole thing over there, but I didn't do that because I figured most of you'd probably move the 3 first, which is totally fine. It really is totally fine. So I'm going to give me negative 4 sine squared x equals negative 3. Let's say minus 3. I just subtracted 3 from both sides, okay? So now I want that sine squared x by itself. I'm going to divide both sides by a negative 4. So that will give me sine squared x equals 3/4. Okay, because a negative divided by a negative is a positive. Now that I have sine squared x equals a number, I really don't care what sine squared x is. I want to know what sine is. How do I undo a square? Square root. That hasn't changed. So I'm going to take the square root of both sides. When I do that, on the left, I'm left with sine of x On the right, because I introduced the square root, what do I need to put? Plus or minus. Plus or minus, and then taking the square root of a fraction is super easy. I take the square root of the numerator. Square root of 3 is square root of 3. Square root of 4 is 2. Okay. Everybody with me so far? Now I have sine of x equals some value. That's when I get to do the inverse, but I'm going to say, all right, I need to know, well, I need sine to be positive and negative, so really that takes care of all 4 quadrants, right? So then what angle gives me a sine value of the square root of 3 over 2? Pi thirds. And then I need, that's my first quadrant. What's my second quadrant? 2 pi thirds, good. Third, 4 pi thirds, good. Fourth, 5 pi thirds, there you go. And I have 4 answers this time. Okay. What questions do you have? Easy enough? It's the same. The algebra stuff is the same. Whether I put logs in there or trig in there or whatever, it's really the same steps. And sometimes you just have to remind yourself of that because it looks weird and it looks different, but you can totally do it. All right. So here it says, what are all the values of theta? So it does have the word all, but it's still giving me this here where this is true. So let me just rewrite that. Oops, well, it helped if I wrote the right thing. All right, so cosine squared theta equals negative cosine theta. Okay, here's what I'm not going to do. I am not going to take the square root of both sides because I see a square here. I was able to do that here because I had a variable squared equals a value, not what I have here, and I don't want to end up with the square root of cosine theta because that I don't even know what to do with that. Here's something else I am not going to do. I am not going to divide both sides by cosine. Okay, we lose a root that way. So let me take you back to something with x's. If I have 2x squared equals x, okay? If I divide both sides by x, that would give me, let me just write that down here, 2x equals 1, so x would equal 1/2, okay? Seems legit, like it would work, right? But what I really need to do is move that over and get 2x squared minus x equals 0. Factor out an x, so I get 2x minus 1 equals 0 like that. This is what that becomes, but I also have an x equals 0. So you see how when I just divide, I lose a root? Like this guy just went away. He disappeared, and we can't let him disappear because he's important. So if you subtract something and it subtracts away, that's different. But don't go dividing both sides to try to get rid of something. You lose a root there. Okay? Do you understand what I'm trying to say there and why? So what I'm going to do is this. If I have a squared, what kind of equation is that? It's quadratic. So with a quadratic, I want to set everything to 0, right? That's my first step. So I'm going to move this over here and get cosine squared theta plus cosine theta equals 0. Everybody with me on that? Then I look at it and say, can I factor out a GCF? What's my GCF? Cosine theta, right? So if I factor out cosine theta, that leaves me with cosine theta plus 1, and all that equals 0. The factoring rules, exact same as if it was just a theta or just an x and doesn't have a cosine on it. Everybody okay with where everything came from? Okay, so now that I have that split, I'm going to split it right here where I have my 2 factors, and I'm going to use my zero product property just like we would if it was, looked like something else. So I'm going to take this and have cosine theta equals 0, and cosine theta plus 1 equals 0. Okay. Just like I basically would have done here. Like we kind of skipped the equals 0 part over here now just because we know what we're doing. It's okay to even skip this one and just go ahead and say cosine theta equals -1. -1. It's okay to just skip that one and just write that. I just didn't want to lose everybody on the first one. So now basically I have two separate little pieces of where we started yesterday. And I would look at this and say, okay, what angle gives me a cosine value of 0? What are they? Pi halves and 3 pi halves, right? So theta is equal to pi halves and 3 pi halves. And then -1, what angle gives me a cosine value of -1? Pi. So theta equals pi. So I have a total of 3 answers, and I'm going to put them all together in order. So I would have pi halves, then pi, then 3 pi halves. Okay. What questions do you have? Anything? All right. We all good on the factoring, right? Okay. So let's look at this next one. I have f of x and g of x. And in the xy plane, what are the coordinates of the points of intersections of the graph of f and g? And again, it gives me from 0 to 2 pi. So what do I need to do to set this up? Set them equal to each other. So I'm going to get 2 sine squared x equals square root of 3 sine x. So once again, I am not taking the square root of both sides because I don't have a squared equals just a plain old number. I'm also not dividing it out because that's illegal. So it's a quadratic. I set it equal to 0. 2 sine squared x minus the square root of 3 sine x equals 0. And then since it's not a trinomial, I can't, factor it into 2 binomials, but can I factor out a GCF? What's my GCF here? Sine of x. Very good. So I'm going to factor out a sine of x. That leaves me with 2 sine x minus the square root of 3 equals 0. Okay. So I have it factored as much as I possibly can. So I'm going to split this here and have sine of x equals 0 and 2 sine of x equals square root of 3. So I skipped one step there just to kind of ease you into it because I would set that equal to 0, and then when I did, I just moved that over, which means here I actually end up with sine of x equals square root of 3 over 2. Okay. So then on the left-hand side, I know that would be a quadrantal. What angle gives me a sine value of 0? When is sine 0? At what angle? At 0, right? And pi? And 2 pi, but do I include 2 pi? No. I can only use 0 and pi here. If that was included, then I might have 3 answers just if I knew, but that's more likely how you're going to see it. So x equals 0 and pi. Over here, I've got sine is positive in which quadrants? First and second, right? Okay, what angle gives me a sine value of the square root of 3 over 2? Pi thirds. So I need pi thirds, and then I need my second quadrant pi thirds, just 2 pi thirds. I put all that together in order. 0, pi thirds, 2 pi thirds, and pi. What questions do you have? Anything? Okay, we need to do a couple more that I didn't put on here. So go ahead, if you go ahead and fold it like you're going to fold it, and then you can flip it up and you can write on the back, but that way you know how to do it right side up. I'm going to leave out all the words, and we're going to use this range. We're still going to go from 0 to 2 pi, and basically I'm going to give it to you like after you would set it up, just so we don't have to write a bunch of words down. So here's example 9. I give you sine squared x equals 2 sine x plus 3. Okay. All right, so once again, not going to take the square root of both sides because that wouldn't work. That wouldn't make any sense here. And even dividing by sine really wouldn't make any sense here, even if you think it makes sense on the others. But it's a quadratic. I'm going to set it equal to 0. So sine squared x minus 2 sine x minus 3 equals 0. Can I factor out a GCF here? No, because I have signs here and here, but that -3 doesn't have a sign on it, right? There is no GCF that I can factor out. But I do have a trinomial this time. And if I think about the signs just as x's and think about having x squared minus 2x minus 3, that's something we can factor, right? So we're going to, and a is 1, that's great. So we're going to factor this into 2 binomials. Just like if this was x squared and I'd put x and x, this time I'm going to put sine of x at the beginning of each one. And then I need 2 numbers that multiply to give me a -3, combine to give me a -2. What are they? -3 and 1. Okay, you see how easy that is? If you understand factoring like you should, especially when the numbers are decent, even when we put weird trig stuff in there, we can still factor. We're not freaking out. We're not making up math. Okay, we all good? All right, so then just like on the other one, I'm going to split this. And that'll give me here that sine of x equals 3 and sine of x equals -1. Okay. So then I ask myself, what angle gives me a sine value of 3? Is 3 even a number that we've used in any of that? No. Okay, so I just want you to think about this real quick. Here's my sine parent function. That gives me all of the y values there, all of my sine values, even the ones in between that we don't know without a calculator. But what's the largest sine value I can have? What's my maximum? 1, and my minimum is -1. So the sine value, unless there's some sort of transformation, it's never going to equal 3. Sometimes this happens. When you factor or when you're trying to solve, you get something that makes absolutely no sense. So this part just does not exist. Okay, or undefined, however you want to put it. Doesn't really matter, just doesn't exist. So then over here, sine of x, when does the sine value give you -1? Or what angle gives me a sine value of -1? 3 pi halves, right there, right? So x equals 3 pi halves. So then my only answer is 3 pi halves. Okay. So sometimes you end up with like 5 answers. Sometimes it's just 1. I mean, it just depends on what's happening with the graph. Any questions at all? Okay. So you can either move it over to the right, or you can just keep, can unfold your paper and just keep going. I just wanted you to fold it so you know which direction to write on it. And then what number was that? That was 9. Okay, so we just have one more. 10. So you don't have to conserve space or anything. Sine of x times, oops, forgot my x. Sine of x, goodness gracious, times cosine x equals sine of x. Okay, so square root here definitely doesn't make any sense. Dividing by sine, still illegal. I would totally just knock out an answer. or a possible answer. I mean, I guess I could have knocked it out and it'd have been like undefined, and then maybe I got lucky, but we're not going to bank on getting lucky here. When in doubt on what to do, because I know it doesn't look like a quadratic as you think of a quadratic or anything like that, and that's fine. But when in doubt, set it equal to 0 and see what you can do. Okay, so we're going to move this sine of x over. So this gives me sine of x times cosine x minus sine of x equals 0. So now that I've done that, can I factor out a GCF? Yes. So I can factor out a sine. That leaves me with cosine x minus 1 equals 0. So I wanted you to see that sometimes you get, it's not all sines or not all cosines. Sometimes they're mixed, but we have to be able to split them to be able to solve it. And we can split it. It works. So then I'm going to mark these off here. I get sine of x equals 0 and cosine x equals 1. All right. So what angle gives me a sine value of 0? 0 and pi, okay? X equals 0 and pi. Right. What angle gives me a cosine value of 1? 0. X equals 0. So it showed up twice. It's okay. It's like having a double root, right? And so that means that x is equal to 0 and pi. What questions do you have? Now, I know you won't all admit it, but some of you, when you start solving these, you're actually going to like it because they're like little puzzles, and you'll probably even impress yourself because it looks real gross and real difficult, but you're like, look at me, I'm doing this, and I got my answer, and be proud of yourself, okay?